Question 12c. Let f of x equal inverse sine x plus inverse cos x. Part 1. Show that f dash of x equals 0. The first derivative of inverse sine x equals 1 over the square root of 1 minus x squared. The first derivative of inverse cos x equals negative 1 over the square root of 1 minus x squared. Now f dash of x is equal to the sum of these two derivatives, so that equals 1 over the square root of 1 minus x squared plus negative 1 over the square root of 1 minus x squared, which equals 0 as required. Part 2. Hence or otherwise, prove inverse sine x plus inverse cos x equals pi over 2. F of x is a constant value in the domain x greater than or equal to negative 1 and less than or equal to 1 since f dash of x equals 0, which was shown in part 1. Now we can find the value of the constant by choosing a value of x in the domain and evaluating f of x for that chosen value of x. Now we can choose x equals 0, which is in the center of this domain. So f of 0 equals inverse sine of 0 plus inverse cos of 0, which equals pi over 2. Therefore, inverse sine of x plus inverse cos of x equals pi over 2 as required. Part 3. Sketch f of x equals inverse sine x plus inverse cos x. The following is the graph of y equals f of x, where f of x equals inverse sine x plus inverse cos x. Notice that it's a horizontal line from x equals negative 1 to x equals 1 inclusive, which is why we have the closed circles here and here. Also note that the y-intercept is pi over 2. It's a horizontal line because the first derivative, f dash of x, equals 0 over the domain of f of x. Scan the QR code to access the HSC revision video catalogue.